The letter you type on your keyboard, how is it handled by your computer behind the scene? How does your computer know what you typed? And what is the process behind it? Stay tuned to find out. The letter you see on the screen when you type it on the keyboard is handled by ASCII behind the scene. ASCII stands for American Standard Code for Information Interchange. There are two more character encoding tools that were invented after ASCII, which made our job even more easier. We'll get into them later in this video and also in another episode. ASCII is a character encoding tool used and is still being used in computers. Think of ASCII as a clothes or shoe size chart that has the American size on the left side and the European size on the right side. It tells us that American size 11 equates to 44 European size. It's the same thing with ASCII. It has binary on one side and the equivalent decimal values on the other side. Now what does it do? When I press a key on the keyboard, let's say the letter B, it generates a binary number. My computer takes it to where the chart is located. It's either in memory or CPU, I don't know where that chart is. And it tries to find the matching binary number. Once it found it, it will look to see what character is associated or linked to that binary number. It takes it and displays it on the screen for me. Now, when did we start using ASCII? And what were we using before ASCII? ASCII started first in May 1961. And before that, each computer manufacturing company was using their own encoding method, which only the internal computers within those companies could use them to communicate to each other. As a result, they couldn't talk to other computers in another company, which caused an issue within the computer industry. And the issue was that, let's say in company A, the letter B had the numerical value of 2. For example, this is not the actual value. The same numerical value in another company meant a completely different thing, like C instead of B. They wanted a universal code for every computer. So what they did was they sent a request to ASA, now it's called ANSI, which stands for American National Standard Institute, to make ASCII the universal encoding method so all computers, no matter what company made them, could communicate to each other. It was not successful at the beginning though, but over time it became the mandated computer encoding code in America. The way it worked was it gave every character a number. It gave 65 to capital A, 66 to capital B, and 97 to lowercase a, and so on. So when someone sent number 66, the computer would know to show the capital B. It made everyone's job so easy. But it had a downside. Because ASCII was using 7 bits of binary and not the full 8 bits, it could only represent 128 characters, which included only the English letters, both capital and lowercase, plus numbers, and control commands like backspace, space, and similar controls. Because it didn't use the last bit, it didn't have the capability to represent the letters from other languages like Spanish or French. What they decided to do was they said, let's use the last bit too, man. And they did. It gave them 256 characters instead of 128. And this time, it allowed them to represent letters that have accents on them, like these few letters from Spanish. Also, line drawing characters, and more. Quite impressive, isn't it? Well, it's good that we have the accent letters now included, but what about Arabic or Chinese letters? Chinese alone has over 50,000 characters. How are we going to represent them in our computers? By the way, the upgraded version of ASCII was called Extended ASCII. This is when they said, we gotta come up with something else. And they sure did. They invented Unicode. Unicode could and can represent about 100,000 different characters or even more. And you know what the cool part is? It's ASCII compatible, which means that for the first 256 characters, it uses ASCII. What else is so special about Unicode? If you want to find out, I have a dedicated video coming up soon that dives deeper into Unicode and its properties. So make sure to subscribe and hit the notification bell to get notified when it comes out. That was all for this video. Now you know what happens behind every click you make and every key you press on your keyboard and how they are processed. There's more to encoding methods, but this information will get you started for next phases. If you found this video helpful, Don't forget to share it with friends and family so they can benefit from it as well. See you next time.